Picture this: September 6, 1859. The largest ship ever built, 692 feet of iron and steam, is conducting sea trials off the English coast. In the Grand Saloon, Victorian luxury meets cutting-edge engineering, ornate woodwork, crystal chandeliers, plush seating for hundreds. Below deck, massive boilers generate enough steam to power this floating city across the Atlantic. Then, without warning, the world explodes. A boiler detonates with the force of a bomb. Scalding steam at 300 degrees rips through the ship's interior like an invisible knife. The Grand Saloon, that showcase of Victorian elegance, becomes a death chamber. 5 crew members, maybe 6, die instantly, their bodies found later amid the wreckage of twisted metal and shattered dreams. The ship's creator isn't there to witness it. Isambard Kingdom Brunel lies dying in his London bed, already felled by a stroke. When news of the explosion reaches him, he'll say just 4 words: "It will break my heart." 10 days later, he'll be dead, at 53 years old, his body destroyed by decades of 18-hour workdays and 40 cigars a day. But here's the thing that makes this story so much darker. This explosion wasn't the first disaster. It wasn't even close. This was a man who built a railway tunnel that killed over 100 workers. A man who nearly died himself in a catastrophic flood while building the world's first underwater tunnel. A man whose failed atmospheric railway cost £350,000 in 18 months. That's roughly $50 million in today's money, gone in a year and a half. A man whose ships bankrupted companies and whose ambitions destroyed fortunes. The Victorian press called him Britain's greatest engineer. Modern historians call him a genius. His investors called him a lot of other things. So who was Isambard Kingdom Brunel? A visionary who pushed the boundaries of what was possible? Or a dangerous madman whose megalomania left a trail of bodies and bankruptcies across Victorian Britain? The answer, like most things in his life, is complicated. And it starts with a father who nearly ended up losing his head in revolutionary France. What made a man so obsessed with building the impossible that he'd sacrifice everything, including hundreds of lives and his own health, to make his visions real? Before we dive deeper, if you're into stories about the geniuses and madmen who built our modern world, the ones who changed everything and destroyed themselves in the process, hit that subscribe button. And let me know in the comments if you'd ever heard about Brunel before watching this. I'm betting most of you haven't, even though you're living in a world his innovations made possible. Now, to understand Brunel's story, you need to understand Victorian Britain. Think of it like the tech boom of the 2000s, except instead of Silicon Valley startups competing to disrupt industries with apps, you had engineers competing to disrupt the world with steam engines, railways, and ships. And instead of venture capitalists, you had railway companies and shipping magnates throwing money at anyone with a big enough vision. The stakes? Absolutely massive. Britain in the 1830s and 40s was in the middle of the Industrial Revolution. Steam power was transforming everything: manufacturing, transportation, daily life. The country that controlled steam technology would control global trade. It was like the race for artificial intelligence today, except the technology actually worked and could definitely kill you. Railways were the internet of the Victorian era. By 1850, Britain had built 3,000 miles of track, employing 250,000 workers. Fortunes were made and lost on railway speculation. People called it railway mania, and like the dot-com bubble, a lot of people got very rich, and a lot of other people lost their shirts. But here's what they don't tell you in school. This progress had a body count. There were no safety regulations, none. No workers' compensation, no employer's liability if someone got killed on the job. The Victorian attitude was basically laissez-faire capitalism. Let business do whatever it wants, and don't ask too many questions about the broken bodies along the way. Workers organized their own sickness funds, pooling their money, so if you got injured, you might get 1 shilling and 6 pence per day. If you died, Your family got nothing unless your fellow workers took up a collection. The government's position was that this was just the cost of progress. And into this world walked Isambard Kingdom Brunel, a man who would take Victorian ambition and crank it up to 11. A man who looked at impossible as a personal challenge. A man who would build the longest tunnel, the biggest ships, the fastest railways, and wouldn't let anything as trivial as physics, economics, or human mortality stop him. Think of the competition between inventors back then like the feuds between tech companies today. Brunel versus the Stephenson family was like Apple versus Microsoft. The broad gauge railway debate was like the format wars between Betamax and VHS, except with millions of pounds and national prestige at stake. Patent disputes got vicious. Engineering reputations made and destroyed fortunes. And unlike today's tech bros posting on social media, these guys were building things that weighed thousands of tons and could, and did, kill people when they went wrong. Engineers were celebrities. The press covered their projects like we cover space launches today. Public demonstrations of new technology drew thousands of spectators. When Brunel's ships launched, crowds packed the dockyards. When his trains ran, newspapers breathlessly reported every detail. But fame is a double-edged sword. Success made you a national hero. Failure made you a national joke. And Brunel was about to experience both extremes. But where did this obsession come from? To answer that, we need to go back to revolutionary France and a father who barely escaped the guillotine. Isambard Kingdom Brunel was born on April 9, 1806 in Portsmouth, England. But his story really starts 20 years earlier in France, with his father. Marc Isambard Brunel was a French engineer living through the French Revolution. Not a great time to be an educated professional, let alone one with connections to the aristocracy. While the terror raged and heads rolled, Marc was smart enough to see that staying in France was a terrible idea. He escaped to America, then eventually made his way to England, where he married Sophia Kingdom, a woman who'd survived her own imprisonment during the Revolution. Think about that for a second. Both of Isambard's parents had lived through revolutionary violence, had seen what happens when society tears itself apart. They'd survived by being smarter and luckier than the people who didn't make it. Is it any wonder their son grew up with something to prove? Marc Brunel was brilliant. He invented machinery for making pulley blocks for the British Navy, revolutionizing ship construction. He designed sawmills. He engineered bridges. He tackled problems other engineers said couldn't be solved. The lesson young Isambard learned? Impossible just means nobody else has figured it out yet. But here's the thing that would shape Isambard's entire life. He was short. Like, really short. Just over 5 feet tall in an era when height meant power and respect. Picture being this engineering genius trapped in a body that made Victorian gentlemen literally look down on you. Isambard dealt with it by wearing the tallest top hats he could find and developing an absolutely massive personality to compensate. His education was extraordinary. Marc sent him to France, yes, back to the country that had tried to kill his parents, to study at the prestigious Lycée Henri IV in Paris. Then he studied at the University of Caen. By 14, he was back in England working in his father's office, learning practical engineering. And this is where you see the difference between Isambard and other engineers of his time. Most engineers came from working-class backgrounds, learned their trade through apprenticeships, built their skills gradually. Isambard had formal mathematical training, classical education, and artistic sensibility combined with hands-on practical experience. He could calculate stresses and strains in iron beams and also design a bridge that looked beautiful. He was like a Renaissance artist who happened to work with steam engines and iron instead of marble and paint. By his late teens, he was working as his father's assistant on the biggest, most dangerous engineering project in Britain, the Thames Tunnel. This was 1825. Nobody had ever built an underwater tunnel before. The Thames River was basically an open sewer, filled with industrial waste, human sewage, and the bodies of people who fell in and didn't make it out. Building a tunnel under it meant working in some of the most disgusting, dangerous conditions imaginable. Mark Brunel invented a tunneling shield, basically a massive iron framework that protected workers while they dug. Imagine a giant iron cage divided into compartments. Workers stood in each compartment, removing soil bit by bit, while the shield protected them from the millions of gallons of sewage-laden water pressing down from above. Behind them, other workers installed iron segments to line the tunnel. Young Isambard became the resident engineer at age 20. He was in charge of making his father's vision real, and he was about to learn that sometimes reality fights back. The work was hellish. The tunnel was lit only by candles and oil lamps. The air was thick with methane gas that would explode if it touched a flame. Workers suffered from temporary blindness, constant diarrhea, splitting headaches. The temperature would swing 30 degrees Fahrenheit within an hour. Men worked standing in human waste, in darkness, knowing that at any moment the Thames could break through and drown them all. And on January 12th, 1828, that's exactly what happened. The flood that day would nearly kill Brunel and teach him a lesson he would never forget: that to build the impossible, men have to die. The Thames Tunnel flood of 1828 was one of those disasters that seems inevitable in hindsight, but caught everyone by surprise at the time. They were nearly halfway across the river, the tunnel extending into the darkness under London. The work had been going well. Well as work could go when you're tunneling through a riverbed that's mostly sewage and clay. The tunnel shield was moving forward. The iron lining was holding. They were making progress. Then the ground ahead started changing. The clay was giving way to gravel and water. The chief sinker, a guy named Collins, told Brunel something was wrong. The miners were breaking through into loose, water-saturated ground. Every shovelful they removed let more water seep in. Brunel made a decision. Keep going. They were so close to breakthrough. If they stopped now, they'd lose momentum, maybe lose funding. The risk seemed manageable. After all, they had the shield. They had pumps. They had his father's brilliant design protecting them. It was January 12th, 1828. Brunel was in the tunnel, personally supervising the work, when the Thames decided to teach him a lesson about hubris. The ceiling above the shield gave way. Not slowly, not with warning. Just gave way. Hundreds of thousands of gallons of sewage-filled Thames water poured through the opening. The force was indescribable. It was like God had opened a fire hydrant the size of a building. Workers scrambled for the shaft, fighting against the water that was rising faster than they could climb. In the darkness, men were swept away, slammed against iron walls, dragged down into the murky flood. The candles went out instantly, plunging everything into absolute blackness. The only sound was water and screaming. Brunel was swept off his feet. The current slammed him against the tunnel wall. He went under, came up gasping, went under again. In the pitch dark, in water that was equal parts Thames and sewage, he couldn't tell which way was up. His lungs were burning. His limbs felt like lead. He would have died there. But somehow in the chaos and darkness, other workers grabbed him. They dragged him to the shaft, hauled him up the spiral staircase that led to the surface. When they pulled him out into the January air, he was unconscious, his lungs full of Thames water, his body battered from being slammed against the ironwork. Two senior miners, Collins and Ball, weren't so lucky. Their bodies were found days later when they finally pumped out enough water to search the tunnel. Brunel's injuries were severe. Internal damage, broken ribs. The Thames water had done terrible things to his lungs. The doctors told him to rest, to recover, to maybe think about a different career. He was 22 years old and had nearly died in one of the most horrific ways imaginable. His response? As soon as he could walk, he went back to the tunnel. But here's where the story gets interesting. The flood had destroyed the tunnel's momentum. Funding dried up. The Thames Tunnel project would take another 15 years to complete, finishing in 1843. By that point, Isambard had moved on to other projects. The tunnel that nearly killed him became his father's obsession, not his, because Brunel had learned something in that sewage-filled darkness. He'd learned that he could face death and come back. He'd learned that impossible was just a matter of willpower and engineering. And he'd learned that if you wanted to build something truly revolutionary, people were going to die, and you had to be okay with that. Most importantly, he'd learned that his father's generation moved too slowly, too cautiously. Marc Brunel took 18 years to finish that tunnel. Isambard was going to change the world faster than that. While recovering from the flood, Brunel threw himself into design competitions. He submitted plans for bridges, docks, railway lines. He was desperate to prove himself, to step out of his father's shadow, to show that he wasn't just Marc Brunel's short son who'd nearly drowned in a sewer. In 1831, at age 25, he entered a competition to design a suspension bridge across the Avon Gorge at Clifton, near Bristol. The gorge was 700 feet across and 240 feet deep. Most engineers said it couldn't be done. Thomas Telford, the godfather of civil engineering, the most respected engineer in Britain, said Brunel's design was too ambitious, too risky. Telford suggested his own design instead, something more conventional, more proven. But here's the thing, Telford was 74 years old and represented everything Brunel hated about cautious, incremental engineering. The judges rejected Telford's design and chose Brunel's. It was his first major victory, and it must have felt incredible. The young upstart who'd nearly died in a sewer tunnel had just beaten the most famous engineer in Britain. But building the bridge would take money, lots of money. And Brunel had just learned the most important lesson of Victorian engineering. Having a great design means nothing if you can't find investors willing to bet their fortunes on your vision. He needed a project that would make his reputation and his fortune. He needed something bigger than a bridge. He needed something that would change the world. And in 1833, he found it, the Great Western Railway. But what Brunel didn't know was that this railway would require building a tunnel through solid rock, a tunnel that would kill more workers than any other construction project in Victorian Britain. In 1833, a group of Bristol merchants had a problem. Their city was being left behind. Liverpool was thriving because it had railway connections to the industrial north. London was the capital of the empire. Bristol, once one of Britain's greatest ports, was becoming irrelevant. What they needed was a railway to London. 116 miles of track connecting Bristol to the capital, bringing trade and prosperity. What they got was Isambard Kingdom Brunel, promising them the finest railway in the world. Brunel was 27 years old. He'd nearly died in the Thames Tunnel. His bridge at Clifton was stuck in fundraising limbo. He needed this. And he convinced the Bristol merchants that he was the only man who could build them a railway worthy of their ambitions. Most railways of that era were, frankly, terrible. Rough tracks, poor engineering, constant breakdowns. The Stephenson family, the biggest names in railway building, used standard gauge, 4 feet 8.5 inches between the rails. Why that specific width? Because that's how wide coal mine carts had always been. It was like building the internet based on telegraph wire standards. Functional, but not optimal. Brunel looked at standard gauge and said, "That's stupid. If you want trains to go fast, you need stability. If you want stability, you need the wheels farther apart." He proposed broad gauge, 7 feet and 1/4 inch between the rails. Think about the audacity of this decision. Every other railway in Britain used standard gauge. Building broad gauge meant your trains couldn't connect with anyone else's network. It was like creating a new operating system incompatible with every other computer. The technical term for this is bold. The other technical term is insane. But Brunel could argue. He could show calculations proving broad gauge would be faster, smoother, safer. And the Bristol merchants, desperate for their railway, bought it. They gave him the job of chief engineer for the Great Western Railway. The route from London to Bristol had a problem, though. A big problem. In the way of Brunel's perfectly straight, perfectly level railway stood Box Hill, a massive outcrop of limestone that couldn't be avoided. Most engineers would have routed around it. Brunel decided to go straight through it. The box tunnel would be 1 3/4 miles long, the longest railway tunnel in the world. It would require drilling through solid rock using gunpowder by the ton, employing thousands of workers. It would be dangerous, expensive, and probably impossible. Brunel said, let's do it. Construction began in 1836. Brunel calculated they'd need about 4,000 workers. They'd dig from both ends simultaneously, plus sink vertical shafts to create more working faces. If everything went perfectly, it would take maybe 3 years. Nothing went perfectly. First, finding workers. Railway construction employed men called navvies, short for navigators, because they'd originally dug navigation canals. These were tough men who moved from project to project following the work. They lived in temporary camps near construction sites, worked brutal hours, drank heavily, fought frequently. Think of them as the original gig economy workers, except the gig could kill you, and there was no workers' compensation. For Box Tunnel, Brunel needed thousands of them. At the peak, he had 4,000 men working around the clock in shifts. They earned good wages, for the time, because the work was so dangerous that nobody would do it otherwise. The conditions in the tunnel were beyond hellish. Imagine this. You're standing in a hole barely wide enough for 2 men to pass each other. It's pitch black except for the candles on your helmet. The air is thick with rock dust and gunpowder smoke. Water drips from the ceiling. Or sometimes doesn't drip, sometimes gushes. The temperature is stifling because you're deep underground with thousands of other men, and the only ventilation comes from those shafts they're still digging. Your job? Drill holes in the rock face using hand tools. Hour after hour, striking steel chisels with hammers, gradually making holes deep enough to pack with gunpowder. When enough holes are ready, everyone clears out. The blasting supervisor packs the holes with explosive, lights the fuses, and runs like hell. The explosion sounds like the end of the world. Rock fragments fly like bullets. The concussion wave hits you in the chest. Smoke fills the tunnel. When it clears enough to see, you go back in and start hauling out the rubble. Tons of rock, moved by hand, loaded into carts, hauled to the surface by steam-powered winches. Then you start drilling again, and again, and again. The tunnel consumed 1 ton of gunpowder per week. 1 ton. That's 2,000 pounds of explosives being detonated in an enclosed space every 7 days. And sometimes the explosions went wrong. Sometimes men were still in the tunnel when someone lit a fuse too early. Sometimes the gunpowder detonated prematurely. Sometimes the rock fractured in unexpected ways and the ceiling came down. Sometimes men were drilling when they hit a pocket of methane gas and the candle flame ignited it. The death toll started climbing. First a few workers here and there, then dozens, then more. The exact number will never be known because nobody bothered to record the deaths of individual laborers. But historians estimate over 100 men died building Box Tunnel. 100. Their bodies were buried in unmarked graves near the construction sites. No compensation for families. No investigation into what went wrong. Just, next worker, please. The tunnel must be built. And where was Brunel during all this? Everywhere and nowhere. He designed the tunnel. He set the standards. He demanded perfection. But he also allowed visitors to tour the construction site for 1 shilling each. That's right. While men were dying in the darkness, Brunel was charging tourists admission to watch it happen. Critics at the time said he was putting profit over safety. Brunel said progress required sacrifice. The Victorian press mostly sided with Brunel because the tunnel was a marvel of engineering. Those 100 dead workers? The cost of modernity. In 1841, the two ends of the tunnel met in the middle. They were off by just an inch or two, an incredible feat of surveying and engineering accuracy for the time. The tunnel was lined with 30 million bricks, had perfect drainage, featured elegant ventilation shafts. It was objectively a masterpiece, and it was built on the bones of men whose names nobody remembered. The Great Western Railway opened in 1841, running from London to Bristol through the Box Tunnel. Brunel's broad gauge trains were indeed faster and smoother than standard gauge. Passengers loved them. The railway made money. Brunel became famous. But here's the question nobody wanted to ask. Was it worth it? 100 men dead so that Victorian ladies and gentlemen could travel from London to Bristol in comfort. 100 families destroyed so that Brunel could prove his engineering theories correct. Brunel didn't seem to lose sleep over it. He was already moving on to his next impossible dream, building ships bigger than anyone thought possible. Because if you can build the longest tunnel in the world, why not build the largest ship? And if that works, why not build an even bigger one? And another one after that. Each one more ambitious, more expensive, more dangerous than the last. By the 1840s, Brunel's railway was running and his reputation was established. He was the man who'd done the impossible. But Brunel wasn't the type to rest on his laurels. His mind was already racing ahead to the next challenge. Here's how his brain worked. The Great Western Railway connected London to Bristol. Bristol was a major port. Ships sailed from Bristol to America. But what if you could make that transatlantic voyage faster and more reliable? What if instead of depending on wind and sail, you could cross the ocean using steam power? Most maritime engineers said it couldn't be done. Steam engines consumed too much coal. To carry enough coal for an Atlantic crossing, you'd need such a large ship that the weight of the coal would sink it. It was a mathematical impossibility. Brunel looked at their calculations and found the flaw. They were thinking linearly. Double the distance, double the coal. But ship capacity increases with the cube of its dimensions, while water resistance only increases with the square. Make a ship big enough, and you'd have room for all the coal you needed plus cargo, passengers, and profit. It was like realizing that a bigger hard drive doesn't just store more data. It becomes proportionally more efficient at storage. The math worked. Nobody had tried it because nobody had dared to build a ship that big. Brunel took his idea to the Great Western Railway directors. Why just build a railway? Why not extend it across the Atlantic with a steamship? They could call it the SS Great Western, and it would be the largest passenger steamship in the world. The directors, probably still calculating the costs of Box Tunnel, somehow said yes. Maybe they were caught up in Brunel's vision. Maybe they'd made so much money on the railway they could afford to gamble. Or maybe they'd learned that when Brunel wanted to build something, it was easier to fund it than to argue with him. The SS Great Western launched in 1838. It was 236 feet long, made of wood, powered by side paddle wheels driven by steam engines, and it worked. The ship crossed the Atlantic in 15 days, proving that steam-powered transatlantic travel was not only possible, but practical. Brunel had just obsoleted every sailing ship on the Atlantic. It was like going from dial-up to broadband. Once you experienced the improvement, you'd never go back. But here's where Brunel's personality comes into play. Normal people would have been satisfied. Build one successful steamship, prove the concept, let others refine it. Not Brunel. He immediately started designing a bigger one. The SS Great Briton, launched in 1843, was revolutionary. It was 322 feet long, nearly 50% bigger than his first ship. But more importantly, it was made of iron, not wood. And instead of paddle wheels, it used a screw propeller. Both decisions were controversial. Iron ships. Everyone knew iron sank. The fact that iron weighs more than water meant ships made of iron couldn't possibly float. Except, of course, they could. It's about displacement, not material density. But try explaining physics to 19th century sailors who'd spent their entire lives working with wood. The screw propeller was equally controversial. Paddle wheels were proven technology. Everyone used paddle wheels. The screw propeller was this weird new thing that might work in theory but seemed fragile and unreliable. Brunel built the ship anyway, and it was magnificent. The SS Great Britain could carry up to 250 passengers in unprecedented comfort. It had a dining saloon, a promenade deck, private cabins. It was like a floating hotel powered by cutting-edge technology. The ship's launch in 1843 drew huge crowds. Prince Albert, Queen Victoria's husband, attended. The press called it the most remarkable ship ever built. Brunel had done it again, taken something people said was impossible and made it real. But there's a pattern emerging in Brunel's career, and it's not a good one. The Great Western made money. The Great Britain didn't. Well, not initially. The ship was so expensive to build and operate that making a profit was difficult. Then in 1846, it ran aground in Ireland due to navigation error. The damage cost massive amounts to repair. The ship eventually returned to service and had a long career, including transporting emigrants to Australia. But the immediate financial return? Not great. Investors were starting to notice that Brunel's visions often cost more than projected and took longer to become profitable. And Brunel, rather than learning caution, decided to double down on ambition. While the Great Britain was being built, he'd taken on another project, one that would become his most spectacular failure, the atmospheric railway. The South Devon Railway needed to connect the coastal towns of Devon to the growing rail network. But Devon is hilly. Steam locomotives struggled with steep gradients, burning enormous amounts of coal to haul trains uphill. Brunel proposed an alternative, the atmospheric railway system. Here's how it worked. Instead of a locomotive pulling the train, you'd have a continuous pipe running between the rails. Inside the pipe, you'd create a vacuum using stationary steam engines at intervals. The train would be connected to a piston inside the pipe. The vacuum would pull the piston, and the piston would pull the train. No heavy locomotive, no coal consumption on the train itself, theoretically more efficient. The technology existed and had been proven in short test installations. Brunel proposed building 7 miles of atmospheric railway in Devon, starting in 1847. The problem started immediately. The pipe had to be sealed along its length, except for a continuous slot at the top where the piston arm connected to the train. That slot had to be sealed by a leather flap that would open as the piston passed and closed behind it. The leather was kept flexible by coating it with soap and tallow. Can you see the problem yet? Leather, soap, and tallow along 7 miles of open railway in the British weather with rats. The rats ate the leather. The weather dried out the soap. The seals failed. The vacuum couldn't be maintained. Trains that were supposed to glide smoothly at 50 miles per hour instead stuttered and stalled. During one test run, the vacuum failed catastrophically and the train hurtled backward out of control. Brunel kept insisting it could be fixed. More money, better seals, different materials. The South Devon Railway kept pouring funds into the project. It became clear to everyone except Brunel that the atmospheric railway was a disaster. In 1848, less than 18 months after opening, they abandoned the system entirely. The stationary engines were sold for scrap. The pipe was torn up. The total loss was about £350,000, roughly $50 million in modern terms, completely wasted. This was Brunel's Theranos moment, a technology that worked in theory but failed spectacularly in practice. The difference was that Brunel genuinely believed it would work. He wasn't committing fraud, he was committing hubris. The press, which had lionized him for his successes, started questioning whether Britain's greatest engineer might be fallible after all. The atmospheric railway failure hurt Brunel's reputation and his ego. His response? Build an even bigger ship. Because clearly what this situation called for was more ambition, not less. The ship he was about to design would be so enormous, so expensive, so catastrophically expensive, that it would bankrupt companies, kill workers, and ultimately destroy Brunel himself. And he couldn't wait to start building it. In 1852, while the atmospheric railway disaster was still fresh in everyone's memory, Brunel started sketching designs for a ship that would make his previous efforts look like practice runs. His logic was sound, in a terrifying sort of way. The Great Britain could carry passengers to America. But Britain had another colony that was even farther away, Australia. The voyage to Australia took months, required multiple stops for coal, and was expensive and dangerous. What if you could build a ship large enough to carry enough coal for the entire journey, plus 4,000 passengers plus cargo? You'd need a ship bigger than anything that had ever floated. You'd need a ship so large that existing shipyards couldn't build it. You'd need a ship that would require inventing new construction techniques, new materials, new everything. Brunel called it the Great Eastern. Everyone else would eventually call it Brunel's Folly. The specifications were insane. 692 feet long, 83 feet wide, 30,000 tons displacement. It would be 6 times larger than the largest ship currently afloat. It would remain the largest ship in the world for 40 years after its launch. To put that in perspective, imagine if SpaceX announced they were going to build a rocket 10 times larger than anything that currently existed, using untested technology, with no clear path to profitability, funded by investors who'd already lost money on previous projects. That's what Brunel was proposing. The ship would have 3 forms of propulsion: a screw propeller at the stern, paddle wheels on the sides, and 6 masts for sails, belt and suspenders, and also a backup belt. The hull would be double-layered iron with watertight compartments that would make it unsinkable. It would have 5 massive funnels belching smoke from the boilers. It would have luxury accommodations that would make previous ships look like cargo holds. The estimated cost was £500,000. The actual cost would exceed £730,000 and destroy the finances of everyone involved. Brunel found a shipbuilder willing to attempt this madness, John Scott Russell, a naval architect with his own shipyard on the Thames. This partnership was doomed from the start because it involved 2 massive egos with different visions and 1 impossible ship. Construction began in 1854. The problem started immediately. First, the ship was too large to build perpendicular to the river like normal ships. It had to be built parallel to the Thames, then launched sideways. This meant designing a completely new launching system using hydraulic rams and chains. Second, the shipyard wasn't equipped for a project this size. Everything had to be scaled up. Bigger cranes, bigger forges, more workers, more materials. Cost overruns began before they'd finished laying the keel. Third, Brunel and Russell couldn't agree on anything. Brunel wanted perfection. Russell wanted profit. Brunel would redesign elements mid-construction. Russell would cut corners to save money. They fought constantly, their arguments documented in increasingly hostile letters. Fourth, the workers building the ship kept dying, not from floods or tunnel collapses this time, but from industrial accidents. Men fell from scaffolding. Heavy iron plates crushed workers. Riveting accidents caused burns and injuries. Nobody kept exact counts, but the body count was adding up again. Fifth, the money kept running out. The Eastern Steam Navigation Company, which had commissioned the ship, was hemorrhaging cash. Cost estimates that seemed generous in 1854 were laughably inadequate by 1856. The company kept raising more money, and the ship kept consuming it. By 1857, the ship was nearly complete, but the company was nearly bankrupt. They needed to launch it, finish it, and get it into service before they ran out of money entirely. The launch was scheduled for November 3, 1857. Remember how I said the ship had to launch sideways? Nobody had ever launched a ship this size sideways before. Brunel designed an elaborate system of hydraulic rams, chains, and checking drums to control the descent. In theory, they'd slowly lower the ship down greased rails into the Thames over several tides. Thousands of spectators gathered to watch. The press was there. Investors were there. This was supposed to be Brunel's greatest triumph, the moment that would silence all his critics and prove that his vision was correct. The ship didn't move. They activated the hydraulic rams. Nothing. The Great Eastern sat there, unmoving, like it had been welded to the shore. The spectators started getting restless. The press started making notes about embarrassing failures. Brunel, watching from the shore, must have been dying inside. They tried for hours. The ship moved maybe 3 feet. The tide went out. The launch was postponed. Over the next 3 months, they tried repeatedly to launch the ship. Each attempt was expensive, humiliating, and unsuccessful. Workers died in launching accidents. One man was crushed to death when a checking drum failed. Another fell and was killed. The ship that was supposed to showcase British engineering was becoming a symbol of British failure. The press had a field day. Political cartoons showed Brunel pushing uselessly at his immobile ship. Articles questioned whether the ship was too large to ever be useful. The nickname Brunel's Folly stuck. Investors were fleeing. The Eastern Steam Navigation Company was on the verge of collapse. Finally, on January 31st, 1858, after months of modifications and with the help of higher tides, the Great Eastern slid into the Thames. The launch that was supposed to be a triumphant moment had turned into an expensive disaster. 3 workers had died. The costs had mounted into the catastrophic. The company was bankrupt. The Great Eastern sat in the Thames, incomplete, a 692-foot monument to ambition gone wrong. It needed fitting out, installing all the interior elements, the machinery, the finishing touches. But the company that commissioned it no longer existed. Creditors were circling. John Scott Russell, the shipbuilder, publicly blamed Brunel for the fiasco. Brunel blamed Russell for incompetence and corner cutting. A new company, imaginatively named the Great Ship Company, was formed to complete and operate the vessel. More investors, gambling that they could make the economics work where the previous company had failed. They bought the ship at a fraction of what it had cost to build, which should have been a warning sign, but apparently wasn't. Brunel, exhausted and increasingly ill from decades of overwork, continued overseeing the completion. The ship was his baby. He'd sacrificed too much to let it fail now. 18-hour days, 40 cigars, endless stress. His body was breaking down, but he couldn't stop. In 1859, the ship was finally ready for sea trials. 53-year-old Brunel, looking 20 years older, made a final inspection. He walked the decks of his creation, this ship that was larger than some Victorian towns, this monument to his ambition and others' bank accounts. During that inspection, he collapsed. The stroke that felled Brunel wasn't just bad timing. It was the culmination of 30 years of 18-hour days, constant stress, and physical abuse. But the worst news was yet to come. Brunel's stroke hit him like a hammer on September 5th, 1859. One moment he was inspecting his greatest creation, the next, his body simply gave out. They carried him from the ship to his home in London. The doctor said he needed rest, no stress, no work. This was a man who'd never rested in his life, who thought 16-hour workdays were for lazy people. Rest was not in his vocabulary. The Great Eastern was scheduled for sea trials. The ship needed to prove itself. Investors needed to see that all that money, all those deaths, all that controversy had produced something valuable. The trials would take the ship from the Thames down the English Channel to Holyhead in Wales, demonstrating its seaworthiness, and speed. Brunel couldn't go. He was confined to bed, partly paralyzed, his body finally exacting payment for decades of abuse. But the ship he'd poured his life into was about to sail. September 6th, 1859. The Great Eastern steamed down the channel with hundreds of passengers, crew, investors, and press representatives aboard. Everyone who mattered was there to witness the great ship finally proving its worth. In the boiler room deep in the ship's bowels, the massive steam engines were running at high pressure, powering both the screw propeller and the paddle wheels. Everything seemed to be working perfectly. The ship was fast, stable, impressive. This was it. Vindication for Brunel, profit for investors, triumph snatched from disaster. In the Grand Saloon, Victorian opulence met cutting-edge technology. Passengers and dignitaries celebrated with champagne. Musicians played. The crystal chandeliers sparkled in the gaslight. This was what the future of ocean travel looked like. Elegant, powerful, unstoppable. Then the boiler exploded. Nobody knows exactly what went wrong. A valve stuck shut, maybe. Pressure built up beyond safe levels. The boiler, unable to vent steam, became a bomb. And like all bombs under too much pressure, it detonated. The explosion tore through the ship like the fist of an angry god. The force shot up through multiple decks, erupting through the Grand Saloon floor. Scalding steam at over 300 degrees Fahrenheit filled the elegant room. The forward funnel was blown completely off the ship, launching into the air and crashing back down onto the deck. Metal fragments became shrapnel, slicing through wood and flesh with equal ease. 5 crew members, possibly 6, died instantly. Some were killed by the blast itself. Others were scalded to death by superheated steam. The Grand Saloon, moments before a showcase of Victorian luxury, became a scene of devastation. Shattered wood, twisted metal, broken glass, and the smell of burning flesh and steam. The passengers panicked, understandably. Some thought the ship was sinking. Others thought they'd hit a mine. The reality that the ship itself had tried to kill them was somehow worse. The great unsinkable ship had turned into a death trap. The crew managed to control the situation. The ship didn't sink. The double hull design, the watertight compartments, all of Brunel's safety innovations worked. But the damage to the ship's reputation and to investor confidence was catastrophic. The Great Eastern was supposed to be the safest ship afloat. Instead, it had killed its own crew before completing its first voyage. Back in London, Brunel lay in bed, recovering from his stroke. On September 15th, news of the explosion reached him. According to witnesses, he said 4 words: "It will break my heart." 10 days later, on September 15th, 1859, Isambard Kingdom Brunel died. He was 53 years old. His body, abused by decades of overwork and poor health choices, had nothing left to give. The stroke, the stress, the news of his great ship's failure, it was too much. In his final days, he'd seen his greatest creation become his greatest disaster. The ship that was supposed to cement his legacy as Britain's greatest engineer had instead killed people and bankrupted companies. The atmospheric railway had failed. The box tunnel had claimed over 100 lives. The Great Eastern launch had been a humiliating disaster followed by a deadly explosion. This was not how the story was supposed to end. Victorian heroes were supposed to die triumphant, their works standing as monuments to progress. Brunel died with his reputation damaged, his finances strained, his great ship sitting in harbor as a reminder of how ambition can exceed capability. The funeral was enormous. Engineers, politicians, aristocrats, ordinary citizens who'd ridden his railways or read about his achievements. They mourned the loss of Britain's greatest engineer, the man who'd built the impossible, the visionary who'd changed transportation forever. But here's the uncomfortable truth that nobody wanted to acknowledge at the funeral. Brunel had been killing people for 30 years. Over 100 dead in Box Tunnel. Deaths in the Thames Tunnel. Deaths building the Great Eastern. Deaths in the Great Eastern explosion. How many families destroyed so that Brunel could prove his visions were correct? And for what? The Great Western Railway, yes, was successful, though they'd eventually have to convert from broad gauge to standard gauge, costing millions and proving the Stephensons were right all along. The steamships revolutionized ocean travel. True. But at what cost? The Victorian press praised him as a genius. Modern historians still debate whether he was a visionary ahead of his time or a dangerous egomaniac who prioritized his ambitions over human life. Both can be true. That's the uncomfortable reality. But here's the twist nobody saw coming. The Great Eastern, the ship that bankrupted companies and contributed to Brunel's death, would eventually find a purpose that vindicated his entire vision. After Brunel's death, the Great Eastern became the world's most expensive orphan. The great ship company owned it, but they had no idea what to do with it. The ship was too large for most commercial routes. It consumed too much coal. The explosion had damaged its reputation. Insurance companies charged premium rates because of the disaster. The company tried using it for passenger service to New York. Financial disaster. They tried luxury cruises. Also a disaster. The ship was simply too far ahead of its time and too expensive to operate profitably. It was like building a supersonic passenger jet in an era that could barely keep prop planes in the air. By 1864, 5 years after Brunel's death, the ship had become an expensive curiosity. It had cost over £730,000 to build, roughly $110 million today, and had generated almost no profit. Every company that operated it lost money. Then somebody had an idea that would change everything. In 1858, while Brunel was still alive, the first transatlantic telegraph cable had been laid. For a few glorious weeks, you could send electrical messages from America to Britain almost instantaneously. It was like the first time the internet connected continents. Suddenly, the world got smaller. Then the cable failed. Bad insulation, poor construction, too much voltage from over-enthusiastic operators trying to send signals through thousands of miles of copper wire. The cable stopped working, and the company behind it went bankrupt. The dream of instant transatlantic communication seemed dead. But by the mid-1860s, technology had improved. Better insulation materials, better cable design, better understanding of electrical engineering. What they needed was a ship large enough to carry thousands of miles of heavy cable, stable enough to lay it precisely on the ocean floor, and powerful enough to handle the weight and the ocean's forces. There was only one ship in the world that fit those requirements, the Great Eastern. In 1865, the ship was converted for cable laying. They removed most of the passenger accommodations and installed massive cable-carrying tanks. The ship that had been designed to carry 4,000 people would instead carry thousands of miles of telegraph cable wrapped in waterproof coating. The first attempt to lay the new transatlantic cable in 1865 started well and ended badly. They made it more than halfway across the Atlantic before the cable snapped. They tried to retrieve it from the ocean floor using grappling hooks. Imagine fishing for a lost cable in water 2.5 miles deep. They failed. The cable was lost. Another fortune down the drain. But here's where Brunel's design genius finally paid off. The Great Eastern was stable enough to handle the cable-laying equipment, large enough to carry enough cable for another attempt, strong enough to withstand the stresses of the work. The ship he'd designed for a purpose nobody wanted turned out to be perfect for a purpose nobody had imagined when he designed it. In 1866, they tried again. This time, everything worked. The Great Eastern laid a successful telegraph cable from Ireland to Newfoundland. On July 27, 1866, the first reliable transatlantic telegraph signals crossed the ocean. Britain and America were suddenly connected by instant communication. Then the Great Eastern went back out and retrieved the cable they'd lost the previous year. They repaired it and connected it, giving the world 2 transatlantic telegraph cables. The ship made multiple cable-laying voyages over the next years, laying cables across the Atlantic, the Indian Ocean, from France to America, connecting continents with communications infrastructure. This was the beginning of the modern world. Telegraph cables led to telephone cables. Telephone cables led to internet cables. Today, 99% of international data traffic travels through underwater cables. Every time you stream a video, send an email, or load a website from another continent, you're using technology that started with the Great Eastern laying those first cables. Brunel never knew. He died thinking his greatest creation was a failure. He died believing the Great Eastern was a monument to hubris and wasted money. But the ship he designed found its purpose and changed the world in ways he never imagined. It's a strange kind of redemption. Brunel built the ship for the wrong reasons, but it was exactly the right ship anyway. His vision was correct. He just couldn't see what it would be useful for. It's like inventing the smartphone before anyone had cellular networks. The technology is revolutionary, but it needs the right context to prove its worth. The Great Eastern continued cable-laying work until 1874. After that, it was used as a floating exhibition hall, an advertising billboard, even briefly as a music venue. By 1888, the ship that had cost 730,000 pounds to build was sold for scrap for 16,000 pounds. But the legacy remained. The cables it laid connected the world. The engineering innovations it pioneered influenced shipbuilding for generations. The double hull design saved countless lives. The watertight compartments became standard safety features. And Brunel's other works? The Great Western Railway still operates today as part of Britain's rail network. The box tunnel still carries trains, millions of them, over the past 180 years. The Clifton Suspension Bridge, completed after his death in 1864, still stands over the Avon Gorge, elegant and functional, carrying traffic just as Brunel designed. His ships revolutionized ocean travel. The SS Great Britain, after a century of service and decades as a hulk in the Falkland Islands, was retrieved and is now a museum ship in Bristol, beautifully restored. You can walk its decks and see Brunel's genius in 3 dimensions. So was Brunel a genius or a madman, a visionary or a killer? The answer is yes. Let's talk about the uncomfortable truth at the heart of Brunel's story. He was both brilliant and terrible, and those 2 things were connected. His engineering was genuinely revolutionary. The box tunnel is still considered a masterpiece of Victorian engineering. The surveying required to have 2 teams digging from opposite ends of 1.75 miles of solid rock and meet in the middle with only inches of error. That's not just good engineering. That's extraordinary mathematics and precision that would be impressive even today with GPS and laser surveying. His ship designs were decades ahead of their time. The double hull, the watertight compartments, the combination propulsion systems. These innovations saved lives and influenced shipbuilding for generations. When the Titanic sank in 1912, the main reason it killed so many people was because it didn't have enough watertight compartments. Brunel had figured out that problem 70 years earlier. His understanding of materials was revolutionary. At a time when most engineers were still working primarily with wood and stone, Brunel was pioneering the use of iron in bridges, ships, and structures. He understood that material properties would determine what was possible, and he pushed those limits. But here's the thing about genius. It doesn't excuse the body count. Over 100 workers died building Box Tunnel. That's not controversial or disputed. Historians broadly agree on that figure. These weren't deaths from some unavoidable natural disaster. They were deaths from blasting accidents, cave-ins, unsafe working conditions, and a fundamental disregard for worker safety. Brunel could have spent more on safety measures. He could have slowed the construction pace. He could have implemented better ventilation, better shoring, better blasting procedures. All of these would have cost money and time. He chose not to. Was that a choice driven by economics? Partly. Railway investors wanted results fast and cheap. But Brunel also charged tourists a shilling to watch the construction. He was literally profiting from the spectacle of men working in deadly conditions. The Thames Tunnel flood that nearly killed him should have taught him the importance of safety. Instead, it seems to have taught him that death was an acceptable risk. 6 men died in that flood. Brunel survived and took that as evidence that he was somehow destined to succeed, that risks were worth taking because he would ultimately prevail. That's not engineering, that's ego. And the pattern repeated throughout his career. Every project had a death toll. The Great Eastern Construction, the Great Eastern Explosion, the ships, the railways, the tunnels, all built on the backs of men whose names nobody recorded because they didn't matter to the Victorian era's idea of progress. Modern engineers have a term for this: risk management. You identify potential hazards, you calculate probabilities, and you implement safeguards. If the risk is too high, you redesign or abandon the project. Brunel's approach was identify the goal, achieve it regardless of risk, and blame anyone who gets hurt for being careless. This was not unusual for the Victorian era. Workers were expendable. Safety regulations didn't exist. The concept of employers' liability for workplace accidents was decades away. In that context, Brunel was not unusually callous. He was normally callous for his time. But normal for the time doesn't mean acceptable. Other engineers of his era managed to build projects without 3-digit death tolls. The Stephenson family built thousands of miles of railways, and while there were certainly deaths, they weren't approaching the box tunnel's massacre numbers. So what made Brunel different? Ambition? Scale? Speed? He wanted to build bigger, faster, grander than anyone else. He wanted his name in history books, wanted to be remembered as Britain's greatest engineer, and he was willing to sacrifice other people's lives to achieve that. Here's where it gets really complicated. Without that ruthless ambition, we might not have his innovations. If Brunel had been more cautious, more concerned with safety, more willing to accept limits, would he have built the Great Eastern? Would he have pushed iron ship construction forward so dramatically? Would he have proven that transatlantic steam travel was practical? Maybe not. Maybe we needed someone crazy enough to attempt the impossible, regardless of the human cost. Maybe progress requires occasionally having engineers whose ambition outweighs their concern for individual human lives. Or maybe that's just what we tell ourselves to feel better about benefiting from innovations built on other people's suffering. The Victorians called it progress. We call it innovation. Either way, it came drenched in workers' blood. Compare this to modern engineering ethics. Today, if a construction project killed 100 workers, it would be shut down, investigated, and the engineers responsible would face criminal charges. We have OSHA regulations, workplace safety requirements, employers' liability laws. These exist precisely because of projects like Box Tunnel, but they didn't exist then. And Brunel exploited that. He could work men 18 hours a day in deadly conditions because there was no law against it. He could charge tourists to watch because there was no regulation prohibiting it. He could let men die without compensation because there was no requirement to provide it. Was he a product of his time? Absolutely. Was he worse than other engineers of his era? That's debatable. Was he a genius? Unquestionably. Was he also responsible for hundreds of deaths? Also unquestionably. Both things are true. He revolutionized engineering, and he got people killed through negligence and ambition. He was brilliant, and he was callous. He changed the world, and he destroyed families. These aren't contradictory statements. They're all parts of the same complicated person. But there's one more twist to this story that makes it even more relevant to our modern world. If you think Brunel's story is just historical curiosity, think again. We're living through a new era of ambitious engineering, and the parallels are uncomfortable. Look at Elon Musk. Love him or hate him, he's following the Brunel playbook almost exactly. Build rockets bigger than anyone thought possible? Check. Push boundaries until things explode? Check. Pursue visions that critics say are impossible? Check. Work employees to exhaustion in pursuit of ambitious goals? Check. SpaceX rockets have exploded during testing. Musk calls these rapid, unscheduled disassemblies and treats them as learning opportunities. The FAA investigates. The press covers it. But SpaceX keeps building, keeps launching, keeps pushing boundaries. It's the same philosophy Brunel used. Failure is just data. Keep going until you succeed. The difference is that modern rockets don't have people aboard during test flights. When a SpaceX prototype explodes, it's expensive but not deadly. Brunel's explosions killed people. But the mindset? Push forward regardless of failures. Iterate rapidly. Treat setbacks as learning opportunities. That's identical. Or look at Amazon's warehouse conditions. Workers describe grueling hours, intense pressure, inadequate breaks, workplace injuries. The company says they're meeting all legal requirements and that workers are free to leave if they're unhappy. That's exactly the Victorian attitude toward labor. We have more regulations now, but the fundamental tension between efficiency and worker welfare hasn't changed. The difference is that Victorian workers face death from cave-ins and explosions. Modern workers face injury from repetitive stress and exhaustion. The death toll is lower, but the disregard for human cost in pursuit of efficiency is structurally similar. Tesla's production problems with the Model 3 involved workers putting in 12-hour shifts, sleeping in the factory, injuries from rushed production. Musk himself tweeted about sleeping on the factory floor. That's pure Brunel energy. The boss so committed to the vision that he'll work himself to death and expects everyone else to match his intensity. Brunel smoked 40 cigars a day and worked 18-hour days until his body gave out at 53. Musk tweets about sleeping at the factory and working 100-hour weeks. The technology changes, but the obsessive personality type doesn't. Or consider Boeing and the 737 MAX disasters. Boeing pushed to get the plane to market fast, competing with Airbus. They made design decisions that prioritized cost and speed over safety. The MKS system that caused 2 crashes, killing 346 people, was inadequately tested and poorly documented. When engineers raised concerns, management pushed forward anyway, because delay would cost money and market share. That's the atmospheric railway all over again. A system that works in theory, but fails catastrophically in practice. The difference is that we now have regulatory bodies that ground planes and investigate. Victorian Britain just shrugged and said, progress requires sacrifice. The Theranos scandal is another modern parallel. Elizabeth Holmes promised revolutionary blood testing technology that didn't actually work. She raised hundreds of millions in investment, built a multi-billion-dollar valuation, and kept insisting the technology just needed more refinement even when it became clear the fundamental approach was flawed. That's Brunel's atmospheric railway almost exactly. The leather seals eaten by rats, the vacuum systems that couldn't maintain pressure, the trains that ran backward out of control, all signs that the fundamental concept had problems. But Brunel kept insisting it could be fixed because admitting failure would mean admitting his vision was wrong. Or look at modern construction megaprojects. The Big Dig in Boston, originally estimated at $2.6 billion, actually cost $14.6 billion. Dubai's Palm Islands, environmental disasters built by workers in conditions that human rights organizations call exploitative. China's Belt and Road Initiative, massive infrastructure projects with significant worker safety issues and environmental impacts. These are the modern box tunnels and Great Easterns. Ambitious projects that exceed budgets, face safety issues, and prioritize completion over worker welfare. We have more regulations now, better safety standards, more oversight. But the fundamental pattern, visionary leaders pushing ambitious projects with human and financial costs, hasn't changed. Even in software engineering, we see this pattern. Tech startups push engineers to work 80-hour weeks during crunch time. Games companies ship buggy products because delaying would miss the holiday season. The crypto bubble involved projects that promised revolutionary technology but delivered financial losses to millions of investors. Different domain, same pattern. Ambition exceeding capability, promotion exceeding delivery, hype exceeding reality. The question Brunel's story raises is, how much do we tolerate from visionaries? When does ambition become recklessness? When does pushing boundaries become pushing people too far? Modern society has tried to answer this with regulations. OSHA standards for workplace safety, FAA regulations for aviation, FDA approval processes for medical devices, financial regulations after disasters like Enron and the 2008 financial crisis. These exist precisely because we decided that unfettered ambition costs too much in human suffering. But regulations are only as strong as enforcement, and they only exist after disasters prove they're necessary. Box Tunnel killed over 100 workers before anyone seriously discussed tunnel safety standards. The Triangle Shirtwaist Factory fire killed 146 people before workplace safety laws were strengthened. The Challenger explosion killed 7 astronauts before NASA improved its safety culture. We regulate in retrospect, after the bodies are counted. Brunel's projects contributed to that learning curve. The workplace safety regulations we have today exist partly because Victorian-era projects like his killed enough people that society eventually said no more. But here's the uncomfortable question. Would we have Brunel's innovations without his ruthlessness? Would someone more cautious have built the Great Eastern? Would a more safety-conscious engineer have pushed through Box Tunnel? Maybe the innovations would have come eventually from someone else. Or maybe they required precisely Brunel's combination of genius and recklessness. Maybe you need someone crazy enough to attempt the impossible, and that craziness necessarily includes disregarding normal human limits. I don't have an answer to that, but it's worth thinking about when we lionize modern founders and engineers who push boundaries. Are we celebrating necessary innovation or dangerous recklessness? Is there a difference? Brunel's grave is in Kensal Green Cemetery in London. Thousands attended his funeral. But what do we actually remember about him today? In 2002, Mawa Asimi Sain, the BBC conducted a poll asking the British public to name the 100 greatest Britons of all time. Isambard Kingdom Brunel came second. Beat Winston Churchill? Lost only to Shakespeare. Think about that. A man who died over 160 years ago, whose greatest ship was a financial disaster, whose atmospheric railway failed completely, whose tunnel killed over 100 workers, he's ranked as the second greatest Brit ever. Why? Because when you walk through Britain today, you're walking through the world Brunel built. The Great Western Railway still operates. If you take a train from London to Bristol, you're riding on infrastructure Brunel designed in 1833. That's almost 200 years of continuous operation. The Box Tunnel, built with the blood of 100 workers, has carried millions of trains safely through solid rock. The Clifton Suspension Bridge spans the Avon Gorge just as Brunel designed it in 1831. It was completed 5 years after his death, using his plans. It's a Grade 1 listed structure, a tourist attraction, and still carries traffic. Over 4 million vehicles cross it every year. The SS Great Britain sits in Bristol's harbor as a museum ship. After decades as a hulk in the Falklands, it was retrieved and restored to its 1863 configuration. You can walk its decks, see Brunel's innovations in 3 dimensions, understand why this ship revolutionized ocean travel. The Thames Tunnel, the project that nearly killed him at age 22, still exists. It's now part of the London Underground, carrying thousands of passengers daily. the world's first underwater tunnel, built using technology Brunel and his father pioneered. These aren't museum pieces, they're working infrastructure. The stuff Brunel built was so well engineered that it's still functional almost 2 centuries later. That's not just good engineering, that's extraordinary vision and execution. But here's what gets left out of the heritage plaques and museum exhibitions. The cost. Over 100 dead in Box Tunnel, 6 dead in Thames Tunnel floods, 5 or 6 dead in the Great Eastern Explosion. Deaths in construction accidents across all his projects. Investors bankrupted by cost overruns. Companies destroyed by his ambition. The Victorian era built monuments to progress, but the monuments had foundations made of human bodies. Modern engineers study Brunel in school. They learn his innovations in ship design, his contributions to railway engineering, his pioneering use of iron in construction. They don't always learn about the workers who died. Engineering programs focus on technical achievements, not human costs. Is that right? Should we separate the innovation from its cost? Can we celebrate the bridges and ships while acknowledging the suffering that built them? Here's my take. Brunel was a product of his time who happened to be exceptionally talented and exceptionally ruthless. The Victorian era valued progress over people, and Brunel exemplified that value system. He wasn't unusually cruel for his time. He was normally cruel, which is itself damning. But he was extraordinarily talented. His mathematical abilities, his understanding of materials and stresses, his vision of what was possible, these were genuine gifts. The tragedy is that he used those gifts in a system that treated human beings as expendable resources. Would modern Brunel be better? If Isambard Kingdom Brunel were born in 1990 and was designing projects today, would he be a tech founder pushing employees to exhaustion? Would he be an engineer cutting corners to meet deadlines? Would he value innovation over safety, ambition over caution? Or would modern regulations and social norms channel his talents differently? Would workplace safety laws force him to design more carefully? Would liability concerns make him more cautious? Would social media scrutiny make recklessness harder to hide? We'll never know. But I think the lesson from Brunel's story isn't don't be ambitious or don't push boundaries. The lesson is that innovation has costs, and who pays those costs matters. When Brunel built Box Tunnel, he paid in reputation and stress. His investors paid in money. The workers paid with their lives. The benefits, faster travel, economic growth, technological progress, accrued to society broadly. But the costs fell on specific individuals who had no choice and received no compensation. That's the fundamental injustice. Progress is great. Innovation is necessary. But when the people taking the risks aren't the ones reaping the rewards, when the people who might die don't get to decide if the project goes forward, that's not heroic vision. That's exploitation. Modern society has tried to address this with regulations, workplace safety laws, environmental protections, financial oversight. These aren't perfect, and they're constantly being fought by people who see them as obstacles to progress, but they exist because we decided that unfettered ambition costs too much. Brunel's legacy is complicated because he was complicated. He gave us innovations that literally changed the world, but he did it by treating human beings as acceptable casualties. Both things are true. Both things matter. So here's my final question for you. What do you think? Was Brunel a genius whose innovations justified their human cost? Was he a dangerous madman whose ambitions killed hundreds? Was he a product of his time who happened to be exceptionally talented? Can someone be all of those things simultaneously? And more importantly, when you look at modern founders and engineers pushing boundaries, taking risks, moving fast and breaking things, how do you feel about that? Are we repeating Brunel's mistakes with better technology? Have we learned from his story? Should we celebrate or criticize the modern Brunels? The SS Great Britain, Brunel's second great ship, has a wonderful exhibit about him. They present his achievements honestly, both the innovations and the costs. They don't try to paint him as a pure hero or pure villain. They show the complexity, the contradictions, the genius, and the callousness. That's what history should do. Not erase the uncomfortable parts, not ignore the achievements. Show both. Let people make their own judgments about whether the price was worth paying. Brunel died believing his greatest work was a failure. The Great Eastern, the ship that bankrupted companies and contributed to killing him, seemed like a monument to hubris. But that ship laid the first successful transatlantic telegraph cables. It connected continents. It started the process that led to our modern connected world. Every time you stream a video from another continent, send an email overseas, or video call someone on the other side of the planet, you're using infrastructure that traces back to those cables. The cables that needed a ship as large as the Great Eastern to lay them. The ship that only existed because Brunel was crazy enough to try building it. Was it worth it? I don't know. Ask the families of the men who died building it. Ask the investors who lost fortunes funding it. Ask the billions of people whose connected world depends on the infrastructure it enabled. You'll get different answers because there isn't one answer. History is complicated. People are complicated. Progress has costs. And whether those costs are justified depends on who you ask and what they value. What I can tell you is this. Isambard Kingdom Brunel was a brilliant engineer who changed the world and destroyed lives in the process. He was a visionary and a villain, a genius and a killer, a hero and a cautionary tale. He was very much a product of his time and also somehow timeless, because we're still dealing with the same questions his career raises. How much ambition is too much? When does vision become delusion? What's an acceptable cost for progress? Who gets to decide? These aren't Victorian questions. These are eternal questions that every generation has to answer. Brunel's answer was clear. Push forward regardless of cost. Build the impossible. Let nothing stop you, and let history sort out whether it was worth it. History has sorted it out, and the answer is, it's complicated. So what do you think about this story? Had you heard of Brunel before? Do you use any of his innovations today? Traveled on his railways? Seen his bridges? Benefited from the communications infrastructure his ship enabled? Let me know in the comments what you think about the genius or madman question. And if you want to hear more stories about the people who built our modern world, the ones who changed everything for better and worse, hit that subscribe button. These stories need to be told, complications and all, because the truth is always more interesting than the myth. And Brunel's truth is that he was both greater and worse than the legend. He was human, brilliant, flawed, visionary, callous, driven, and ultimately mortal. Killed by the same ambition that made him great. His last reported words were, "I have only just lived long enough." He was wrong. He died too young. His body destroyed by his work ethic. But his works outlived him by almost 2 centuries, and counting. The bridges still stand. The tunnels still carry trains. The ships influence generations of design. And the questions his career raises about ambition, cost, progress, and responsibility, those are immortal. Thanks for watching. Hit that like button if you enjoyed this deep dive into Victorian engineering and its human costs. Subscribe for more stories about the geniuses and madmen who built our world. And let me know what inventor or engineer you want to hear about next. Because history isn't just about the great men and their great works. It's about the workers who died building those works, the investors who funded them, the families affected by them, and the world we've inherited from their choices. Brunel's grave is in Kensal Green Cemetery in London. It's a simple grave for such a complicated man. People still leave engineering drawings and technical sketches as tributes. They remember the genius, celebrate the innovations, and sometimes ignore the cost. But we shouldn't ignore the cost. We should remember it. All of it. The brilliant and the terrible. Because that's the only way we learn from history instead of just repeating it with better technology. The Great Eastern Brunel's white whale was finally scrapped in 1889. It took 2 years to break it apart. The ship that was too big to build easily was too big to destroy easily. Some of its iron went to build other ships. Some became scrap metal for other projects. The ship that connected continents physically ended up scattered across Britain in thousands of pieces. But the connections it made, those lasted. The telegraph cables led to telephone cables, which led to fiber optic cables. The communications revolution Brunel's ship enabled continues today, faster and more complex, but fundamentally the same idea. Connect the world, shrink distances, make the impossible possible. That was always Brunel's gift and his curse, making the impossible possible, regardless of cost. So was he a genius or a madman? Yes, both. Always both. And maybe that's the most important lesson. The categories we use to understand people, hero or villain, genius or madman, visionary or reckless, these aren't mutually exclusive. They're all just different facets of complicated human beings, doing complicated things in complicated times. Brunel was all of these things. He still is, in memory, and in the infrastructure he left behind. Every time you ride a train through Box Tunnel, you're riding through his genius and his callousness simultaneously. You can't separate them. They're built into the same structure. And that's the world we live in, built by complicated people making complicated choices with complicated consequences that we're still dealing with generations later. Remember that next time someone promises to build the impossible, ask not just can they do it, but what will it cost? And who pays the price? Because Brunel showed us that you can build anything if you're willing to sacrifice enough. The question isn't whether we can build the impossible. The question is whether we should, and at what cost. Thanks for sticking with this long story about a short man who cast a very long shadow over engineering, ethics, and history. Hit that subscribe button, leave a comment with your thoughts. And remember, the past isn't past. We're still living in the world the Victorians built, for better and worse. Until next time, keep questioning, keep learning, and remember that every monument has a foundation. And sometimes that foundation is darker than we'd like to admit. This has been the story of Isambard Kingdom Brunel, the engineer who built the impossible and the man who paid the price, along with hundreds of workers whose names we'll never know.